right, let's finish the idea presented here of whether or not the worldwide flood is corroborated. Seems like it is, by just looking at local floods. Formation of canyons by mega floods, but they're local. They're not worldwide. Unbelievable destruction and change by a small local flood, relatively speaking to a worldwide flood. Go back to K29. K29.htm. What do we got here? We're looking for the end of comment on the formation of canyons by mega floods. We finish this subject off. Bailey, Forsling, and Bigcraft, floods and accelerated erosion in northern Utah. Just pick up these studies here or there. As far as the ordinary smaller materials, sands and silts and clays are concerned, rivers in flood states normally excavate their beds to tremendous depths, carrying vast quantities of sediment along in suspension or along the bed, to be redeposited downstream when the flood subsides. The great action of the Great Colorado River of the western United States is not untypical. From the above description, it is clear that when the Colorado River was in flood, it was acting on the solid rock of its bed down to a depth of over 120 feet from the top of the flood water. It goes down first, then it spreads out laterally, and it's unbelievable destruction. 120 feet from the top of the floodwater. Wow. But that as the current subsided, it first filled up the inner and deep canyon and then covered the rock platform, thus giving no idea of the violence of its section in depth, where it could flush with great force more than 115 feet of sand-filled cuttings. Without such proofs, few engineers would be inclined to believe that silting follows and sand movements down to depths of 50 and 100 feet below normal bed level at each time of a high flood. That's a local high flood. In this kind of activity, Cyril S. Fox says, occurs during present-day floods, which must have been the tremendous quantities of sediment and eroded and transported when rain poured forth all over the earth for at least 40 days without stopping. Lest anyone should object that the heavy stands of antediluvian vegetation may have prevented serious erosion by the floodwaters, we cite the following from the Yale conservationist Dr. Paul Sears. It is often said that deforestation causes floods, and this is a half-truth. Water flows faster and in greater amounts off of cleared land than off of forested land to a certain point. When rainfall exceeds the critical amount, especially on shallow soil such as we have in New England, not even forests will hold it back. So now we have, in addition to that, more corroboration. The destructive power of ocean waves, especially when they're huge. And it must not be forgotten that the flood damages were due not only to the torrential rains pouring from the skies, there were also great volcanic upheavals, evidently unleashing vast amounts of juvenile waters and creating profound disturbances in all the Earth's seas and waterways. Great tidal waves, we know how they go. We've seen them recently. Great tidal waves undoubtedly were generated in prodigious numbers as the imprisoned waters progressively escaped through crustal fractures all around the Earth when the fountains of the great deep were broken up. Even the action of ordinary waves and littoral coastline currents can, over relatively short periods of time, accomplish tremendous amounts of sedimentary work along coastlines when something happens to change the sediment balance normally existing. So we can form a sediment and a geologic strata not in millions of years, but in a few minutes, hours, days. Any unusual conditions, whether natural or man-made, may upset the balance in such a way that when what has been a very stable beach may quickly show significant erosion or accretion. For example, the hurricanes that at times sweep the Atlantic and Gulf coast of the United States frequently produce pronounced changes on the affected beaches. Local, quick, recent. Obviously, the onset of the Noachian flood would have presented profoundly unusual conditions and would have immediately attacked the antediluvian beaches, and the destructive effect of ordinary storm waves is trivial compared to that of tidal waves or tsunamis, such as what must have occurred with great frequency and complexity during the deluge period. Speaking, however, of ordinary waves, King says, waves are seldom more than 25 feet high, but violent storms may raise them to 60 feet, and there are unverified reports of even greater depth. The immense striking power of a wave cannot be realized until it hits an object that cannot float with it. Waves striking the shore of Tierra del Fuego can be heard for 20 miles. Spray from a storm wave has been hurled to the top of a lighthouse nearly 200 feet above sea level. The force of waves striking the shore can be measured and has been found to reach 3 tons per square foot. Worldwide flood. The immense erosive power of such forces should be obvious. Thornberry graphically describes these powers as follows. Waves, particularly storm waves and tsunamis, gigantic tidal waves caused by submarine earthquakes, volcanic eruptions, or slides, are the most important agents of marine erosion. Smaller waves, such as those associated with surf, may carry on attrition of material and minor amounts of abrasion. But just as a stream during a single flood may do more geologic work than it will for months or years at low water stage, so storm waves during a short period may effect more change than ordinary waves will in months. The enormous force exerted by breaking waves is attested to by recorded movements of masses weighing many thousands of pounds. Air in joints and cracks is suddenly compressed and acts as if a wedge were suddenly driven into them. Recession of the water is accompanied by a sudden expansion of air with explosive force. This driving of water into cracks not only exerts great mechanical stress, but in soluble rocks may greatly accelerate solution. W.D. Thornberry quotes Willard Bascom, a leading oceanographer, tells of wind-generated waves exceeding 100 feet in height, and describes some examples of the immense destructive forces that storm waves can develop. Get this, at Cherbourg, France, a breakwater was composed of large rocks and capped with a wall 20 feet high. Storm waves hurled 7,000-pound stones over the wall, and moved 65-ton concrete blocks 60 feet. At Wick, Scotland, the end of the breakwater was capped by an 800-ton block of concrete that was secured to the foundation by iron rods 3.5 inches in diameter. In a great storm in 1872, the designer of the breakwater watched in amazement from a nearby cliff as both cap and foundation, weighing a total of 1,350 tons, were removed as a unit and deposited in the water that the wall was supposed to protect. He rebuilt the structure and added a larger cap weighing 2,600 tons, which was treated similarly by a storm a few years later. Ocean Waves, Scientific American by William Bascom. Probably the most destructive of all waves is that of form of a tidal wave known as the tsunami. Actually, these are not true tidal waves, although commonly called so, but are caused by submarine earthquakes, volcanic eruptions, or slides. They have been known to attain velocities of 400 or more miles per hour and heights of 130 feet to travel extraordinary distances. That's a local event. What about worldwide? Imagine that. 200, 400 mile an hour waves, huge dimensions, 100, 200 feet high, slamming into each other and depositing the sediments that they've taken up. Boulders and rocks get pounded and pushed down to the bottom. And instant formation of fossils and rock strata and rock. The Great Krakatoa earthquake in the East Indies in 1883 created immense waves at least 100 feet high and traveling up to 450 miles per hour, inundating neighboring islands and drowning nearly 40,000 people. A tsunami from this quake was still 2 feet high as it passed Ceylon and 9 inches high at Aden beyond the Arabian Sea. Wow. In 1946, the tsunami originated in the quake in the Aleutian Islands, region traveled 470 miles per hour across the Pacific, creating a 19-foot-high tidal wave on the shores of Hawaii with great destruction. A wave that swept across the Bay of Bengal in 1876 left 200,000 people dead. Imagine 500 miles an hour. How much time do you have to get out of the way? William Bascom. Even more recently, tsunamis generated by the destructive Chilean earthquakes of 1960 have demonstrated once again the power available in this type of wave. A news account states the disastrous series of earthquakes that struck Chile late in May have brought death and destruction to countries on the perimeter of the entire Pacific ports, from Japan to California, from Alaska to New Zealand. The waves that wrecked the coastal villages of Japan a third of the way around the world were 32 feet high. In both Japan and Hawaii, which was struck by 4 waves, there was serious loss of life and extensive property damage. Worldwide flood, what do you think? And it is just this most destructive of all types of waves which must have been produced during the biblical flood by the breaking up of the fountains of the great deep. Furthermore, this breakup with all its attendant destructiveness apparently continued from the first day of the flood through the same period as the great rains from heaven until both were stopped by God 150 days later. Imagine that. Also, the fountains of the deep and the floodgates of the sky were closed, and the rain from the sky was restrained. Genesis 8:2. So, we have tremendous erosion from the flood's rainfall. After all this, an instant change of the entire topography of the world. Where did the rock strata go if they did exist, and they did not? If they were formed over billions of years in this one worldwide flood, it'd be gone. There would be no evidence of it. There's evidence of a worldwide flood. These rock strata are evidence of the worldwide flood. They're not evidence of partial uniformitarianism, slow erosion, a great many years going by. It just happened quickly, that quickly. Great quantities of water were poured down on the earth from the skies, not in the form of gentle drizzle, but as a torrential downpour, continuing without ceasing for 40 days and nights all over the world. Speaking metaphorically, the scriptures say that the floodgates of heaven were open. This pounding rain would first, by its own impact, begin the work of soil and rock erosion. Modern hydrology has proved that raindrop impact is a very significant factor in the initiation of the erosion phenomena. As the waters begin to run off to lower levels, already containing a certain amount of sedimentary load to aid in further erosive activity by the mechanisms of turbulence and attrition, it would begin to form rivulets. These would run finally to the nearest stream, but in the process would deepen their own channels by further erosion. This is the way in which great gullies are formed, often to great depths in a single rainstorm in the present day. For the uniquely intense rainstorm of the deluge, the combined processes of raindrop impacts, sheet erosion, and gully erosion would necessarily have excavated and transported prodigious quantities of earth and rock, even if no other agencies had been available for sediment transfer, and they were. So massive worldwide volcanic, seismic, and tidal wave activity indicated there as well. Great volcanic explosions and eruptions are clearly implied in the statement that all the foundations of the great deep were broken up. This must mean that great quantities of liquids, perhaps the liquid rocks or magmas as well as water, probably steam, have been confined under great pressure below the surface rock structure of the earth since the time of its formation, and that this mass now bursts forth through great fountains, probably both in the lands and under the seas. By analogy with present phenomena associated with volcanism, there must have also been great earthquakes and tsunamis, popularly known as tidal waves, generated throughout the world. These eruptions and waves would have augmented the floodwaters as well as accomplished great amounts of geologic work directly. Complete transformation of the topography of the world. No evidence whatsoever today of the geologic ages. It's all the worldwide flood. Further inferences from the biblical record of the deluge are that there are great amounts of volcanism and great earth movements, both in the early and later stages of the flood period. That these inferences are supported by the field evidence, at least in a general way, is unquestionable. Speak of this next time.